Hi everyone, I'm going to discuss graphing cosecant and secant functions. But before we proceed to graphing or sketching the graph, let us be guided by the guidelines for sketching graphs of cosecant and secant functions. So first, we graph the corresponding reciprocal function as a guide using a dash curve, or not necessarily a dash curve, but initially we will sketch the graph of its reciprocal function. So for example, we want to sketch the graph of y equals a cosecant bx. So we have to make use of its reciprocal function y equals a sine bx as our guide. So initially, this is what we're going to sketch first. Moreover, if we want to sketch the graph of y equals a secant bx, so we have to sketch the graph first of its reciprocal function, and we will use this as our guide function. Okay? And then, after we have sketched the graph of its corresponding reciprocal function, we will sketch the vertical asymptotes. And these vertical asymptotes class are defined by the equation x equals k, where k is an x-intercept of the graph of the guide. So remember, our the guide or our graph guide is the reciprocal. So we are talking here of the graph of sine and cosine function. So after we have sketched the graph, we're going to locate or draw the vertical asymptotes by a broken line. And these vertical asymptotes again are the x intercepts of the graph of the guide. Okay. And then we will sketch the graph of the desired function by drawing the typical U-shaped branches between the adjacent asymptotes. And then the branches will be above the graph of the guide function when the guide function values are positive, and below the graph of the guide function when the guide function values are negative. In short, we're going to sketch the typical U-shaped branch of the desired function opposite the direction of the guide graph. Okay? So let's sketch the graph of y equals cosecant x. Now, we know that its reciprocal function will serve as our guide, and we will make use of y equals sine x. So we're going to select some points from y equals sine x. And you learned in the previous discussion how we come up with selecting points. So we come up with considering quadrantal values. So we divided 2 pi, which is the period of the reciprocal function sine x, by 4. And we got pi over 2. And we will sketch the graph of the reciprocal function by a 2-period interval. So we'll have negative 2 pi until 2 pi. So we'll be adding pi over 2 cumulatively from the lower interval until the upper interval to come up with some values of x. So we have negative 2 pi here. So we'll add pi over 2. So this is negative 3 pi over 2. We'll add pi over 2 again. This will be negative pi. We'll add pi over 2. So this is negative pi over 2. We'll add pi over 2. So this is 0. Then this is pi over 2. This is pi. This is 3 pi over 2. So we'll just add one more column to accommodate 2 pi. And then we'll evaluate its sign value. So sine of negative 2 pi, we know is 0. And sine negative 3 pi over 2 is 1. Sine negative pi is 0. Sine negative pi over 2 is negative 1. So sine 0 is 0. Sine pi over 2 is 1. Sine pi is 0. And then sine 3 pi over 2 is negative 1. And then this is 0. So this will serve class as the x and y coordinates of the reciprocal function of the desired function y equals cosecant x. So we will be sketching the graph y equals sine x. And this is the graph. So we are now going to sketch the graph of y equals cosecant x by first drawing the vertical asymptote, which is defined by its x-intercept. Okay? So the vertical asymptote is defined by x equals k, where k equals the x-intercepts of the graph of the guide function. In here, the guide function is sine x, which is again the reciprocal of the desired function that we are about to sketch. Okay, so we'll draw the vertical asymptotes. And again, the vertical asymptotes are the x-intercepts of the guide function. So we are now going to sketch U-shaped branches, okay, with adjacent asymptotes. So opposite the direction of the curve. Take note, class, that the values of x will never touch the vertical asymptotes. So in short, the vertical asymptotes are the discontinuity of the graph of y equals cosecant x. When we see discontinuity, these are the restrictions on the domain of y equals cosecant x. So the graph of y equals cosecant x has a discontinuity at its vertical asymptote. And the graph of y equals cosecant x has no x-intercepts, wherein the vertical asymptotes are actually defined as its x-intercept. So the period will remain 2 pi, same with its reciprocal function y equals sine x. And the graph has no amplitude since there is no maximum or minimum values. So same also with the guide function or with its reciprocal function. The graph is symmetric with respect to the origin. So let's proceed with the next example. So this time we're going to sketch the graph of y equals secant x. So same with what we did in the first example, we're going to sketch first its guide function, which is the reciprocal of y equals secant x. So y equals cosine x. And same with sine x, the period will remain 2 pi, and we'll sketch the graph over a 2-period interval from negative 2 pi to 2 pi. So we'll divide the period by 4 to come up with quadrantal x coordinate. So this is pi over 2. So we will be adding cumulatively pi over 2 from negative 2 pi over 2 until we reach pi over 2 pi. So we'll add one more column here. So negative 2 pi plus pi over 2, this is negative 3 pi over 2. So we have negative pi here, negative pi over 2, 0, this is pi over 2, pi, 3 pi over 2, and then 2 pi. So this time we'll evaluate its cosine value. So cosine negative 2 pi is 1. Cosine negative 3 pi over 2 is 0. Cosine negative pi is negative 1. Cosine negative pi over 2 is 0. Cosine 0 is 1. Cosine pi over 2 is 0. cosine pi is negative 1, cosine 3 pi over 2 is 0, and cosine 2 pi is 1. Now, after plotting the points, these points, which are actually the points of the guide function y equals cosine x, which is the reciprocal of the desired function here, y equals secant x. So this will be the graph of y equals cosine x. So this is y equals cosine x. So we are now going to sketch the graph of y equals secant x. So we will be drawing the vertical asymptotes, which are the x-intercepts. Okay? Okay. So let's make the asymptotes a straight broken line. Okay. Again. Okay. So let's assume that we are able to sketch a straight vertical broken line, which are the vertical asymptotes. And the vertical asymptotes, again, are defined by the x-intercepts of the guide function. So the vertical asymptote here is defined by quantity 2n plus 1 times pi over 2. And these are the restrictions on the domain of y equals secant x, for x will never be equal to will never be equal to x will never be equal to quantity 2n plus 1 times pi over 2. So in short, the graph has a discontinuity at these values of x, which is the vertical asymptote. So sketching the graph, so this is going to this direction here. Again, the graph will never touch the vertical asymptote. It will become closer and closer, but never touch the vertical asymptote. So this is the graph of y equals secant x. So next meeting, I'm going to discuss how to sketch the graph for tangent and cotangent function. So bye for now.